In this video, I'm going to talk about Ohm's law and its application. Ohm, George Simon Ohm, is a German physicist who derived this law. So if you look at a simple circuit, Ohm's law is a simple formula. If you look at a simple circuit, the current passing through any circuit is nothing but where elements are connected with at least one closed loop. Okay, so here is the circuit. So current passing through the circuit, I is directly proportional to the voltage and I is inversely proportional to the resistance. So if I combine these two, I equal to V over R. Ohm's law is valid only for ohmic materials. Okay, that's the disadvantage of Ohm's law. Now, so to remember this Ohm's law, usually you can V is the king who's going to sit on the top. I and R. To find V, close V with your finger. V equal to I times R. If you want I, close I with your finger. It's V over R. If you want R, R equal to V over I. Now, before this Ohm's law, we already learned about power. So P equal to V times I, right? So here, if I substitute V as an I, if I substitute V equal to I times R, so I times R times I, so it's I square times R. Or if I substitute I value as V over R will end up with V square over R. So P has three formulas. P equal to either V times I, P is the power, or I square times R, or V square over R. P is consumed by the resistor only. Now, the next topic I'm going to talk about series and parallel circuit. So I'm going to compare those two methods. One is resistors in series, another one is resistors in parallel. So how do you know the resistors are in series? So here I'm going to connect three resistors in series. So R1, R2 and R3. Here these three resistors are in series because if you look at a node, at any node, so here let me put one more voltage source. So how many nodes are there in the circuit? There are 4 nodes. Node is nothing but a point where 2 or more elements connected. I can see that's node 1, node 2, node 3 and node 4. There are 4 nodes. So at any node only 2 elements are connected, then those 2 elements are connected in series. So basically at N2 my R1 and R2 only connected, so for sure those two are in series. At N3 R2 and R3 are connected, for sure those two are in series. Now R1 and R3, are they in series? Another way of defining in series is if they are in series, same current passing through each element. Okay, so same current passes through each element. So say for example I ampere is starting from here, the same I is going to be here, same I is going to be there, same I. So there is no current division, so same current is passing through them. As long as same current is passing through them, we can say those elements are in series. So here R1, R2, R3 and the source V, all of them are in series. Now when you say resistors are in parallel, all the resistors must exist between the same nodes. So here how many nodes are there in this circuit? I can clearly see only 2 nodes. So here is node 1 and here is node 2. So R1, R2, R3, here those 3 resistors are in parallel. They must exist between the same nodes. Okay, here current division takes place. So whatever current comes there, I is going to split I1, I2, I3. So current division takes place. Now when I was a student, I always get confused. Say for example, here I'm saying R1 and I current is entering there, I current is leaving there. what is going on then in this resistor? Say for example, if I connect this to a voltage source, okay, so this is a battery, this is a positive terminal, negative terminal. So if you look at a battery, there will be cells, okay, each cell is going to have positive, negative, positive, negative, positive, negative. So these cells are connected in series. If we connect the cells in series, we call that as battery. Say for example, here we'll take a cell where it has positive electrode and negative electrode. So this is positive electrode, negative electrode. There is electrolyte in this battery. Okay, now what happens here? This electrolyte has some energy. What it will do, it will pull electrons from this positive plate and give it to the negative plate. So that's this negative plate become negative because it borrowed electrons from the positive plate. During that process, this electrolyte gives some energy to the electrons. So here, if you look at this battery negative terminal has lots of electrons, okay, with lots of energy in them. Now, whenever I connect it to the circuit, this is a conducting wire, this is a conducting wire, this is also a conducting wire, okay. Whenever you see conducting wire, there are thousands of millions of free electrons, okay. So here, everywhere there are thousands of millions of free electrons. I draw only few electrons. These electrons in the wire, they don't have energy, but whenever I close the circuit, the electrons from the negative plate, they push these electrons in this direction, I mean from the negative plate to the positive plate. So whenever they are passing through this R1, the energy electrons these have, automatically that energy will be transferred to these individual electrons. Whenever these electrons passing through them, they lose that energy, convert that energy into either heat energy or light energy. Now all the empty electrons are going to go through the positive plate. Again, this electrolyte is going to pull the electrons, give it to the negative plate. That's how they carry the energy until that electrolyte has some energy. Another important point, that electron there is going to move very slowly. So electron can move only, I believe it is 10 to the power of minus 4 to 10 to the power of minus 5 meter per second. But the energy, this energy is going to transfer at the speed of light. Okay, so those two are two different things. Those are from the physics. Probably in different video I will explain a little bit. I will explain a little deeper, since here I'm talking about different topic, resistors in series and parallel. Now the next important point is, if the resistors are in series, voltage division takes place. So if the resistors are in series, voltage division takes place. So here I have supply voltage V, so the voltage drop V1 across R1, here V2. So the plus I'm saying between this point and this point, okay, and from N3 to N4, that's V3. Okay, so V total, supply voltage V equal to V1 plus V2 plus V3. Same thing here in the parallel, current division takes place, right? So I equal to I1 plus I2 plus I3. Now here, same voltage across each element. Okay, so when they're in parallel, same voltage across each element. So these two are really important points you need to remember. Now the next one is R total. What is the total resistance when they're in series? R total is, it's a direct addition, R1 plus R2 plus R3. Okay, so here in parallel, R total equal to, or 1 over R total equal to 1 over R1 plus 1 over R2 plus 1 over R3. Okay, so this is another important point you need to remember. So whenever you see series connection or parallel connection, you must remember these 3 points, okay, no matter what. So to practice the examples, you have to remember these 3 important points. The next important point here is So since I'm adding R total R1 plus R2 plus R3, R total is always greater than any one of those resistor. Okay. So in series, R total is greater than highest individual resistor. So if I have R1 equal to 1 ohm, R2 equal to 2 ohm, R3 equal to 3 ohm, then R total must be greater than 3 ohm. Here, if I have R1 equal to 1 ohm, 2 ohms and 3 ohms, R3, then R total is going to be lower than the lowest individual resistor. So R total is going to be lower than 1 ohm resistance here in this case. So that's another important point. Okay, now here I can find V1 equal to I times R1, V2 equal to I times R2, V3 equal to I times R3 because of the same current. Where in parallel case, V1 is same as the V2, same as the V3, same as the V. So V equal to, I can say I1 times R1 or I2 times R2 or I3 times R3 because I1, I2, I3 current is going to divide in this case. Now power consumed P equal to I square times R1 P1 and P2 equal to I square times R2 P3 equal to I square times R3. But since I is same, we're going to use the same I. Where in parallel P equal to or P1 equal to I1 square R1, P2 equal to I2 square R2 and P3 equal to I3 square R3. Instead of that, can I use V times I3? Yeah, you can do that. Same thing here, V times I2, same thing here, V times I1. So you can use any one of those two formulas. Same thing here, P1 equal to I square R1, or I can say V1 times R1. Okay, and P2 equal to V2 times R2. Okay, and P3 equal to V3 times R3. That's the formula to find the power in series and parallel circuit. Okay, I'll stop this video here. I will continue with an example in the next video. Thank you.